Good morning, Carmel High School. No, I'm just kidding. I'm not going to do it like that the whole time. I just wanted to scare my class. Okay, so the 7.8 worksheet, don't look at me like that. 7.8 worksheet, we're going to make things a little bit difficult. Not all of the polynomials in today's lesson will be able to be factored. However, I will give you a hint, and that hint looks like so. So f of -4 equals 0. This tells you a couple things. This tells you, first of all, that x plus 4 is a factor, and that -4 is one of the x intercepts. Okay, so it also tells me that if I were to synthetically divide by -4, -1, -2, 11, and 12, -1, 4, 2, -8, 3, -12, I should get a 0. That's what this tells you. If you synthetically divide by -4, it's equal to the remainder. Okay, so that's what these problems are going to look like all the way through. So we know the number of solutions is going to match the degree, so there's 3 solutions. Okay, since it's an odd degree and the and the leading coefficient is negative, it's going to have up and down end behavior. The y-intercept is going to be the value of y when I evaluate 0, so that would be 0, 12. The turning points is obviously going to be 3 minus 2 or 1. And then the zeros, you already know -4. And what the hint allows you to do is to break down your cubic now into a quadratic. And once you get it to be a quadratic, hopefully you can factor it to find the other zeros. So I would factor out a -1. And then factor x squared minus 2x minus 3 as x minus 3, x plus 1. So the other two zeros would be 3 and -1. So now that I know all 3 of my x-intercepts, -1, 2, 3, 4, -4, -1, and 1, 2, 3, with up and down end behavior, I can rough sketch this. Up and down and behavior. We know that the y-intercept was 12. All right, and we talked about if we wanted to find the relative maximum and the relative minimum, you could just plug in the x values halfway between your intercepts to get those actual values. We're not going to worry about that today. So that's what these guys look like. So moving on, number 2 here, you can see that I have a quartic, and we talked about each time you synthetically divide, you're going to bump the polynomial degree down by 1. The key is to get it to be a quadratic. So if I only gave you 1 0, that would just get you a cubic, and unless that factors, that would be difficult to find. So we have to give you 2 hints here to bump that thing down to a quadratic. Number of solutions is 4. So this is going to mimic the same end behavior as a parabola. And since the leading coefficient is positive, it's going to be up and up. The y-intercept, if I were to evaluate 0, that looks like it would just be 0. Turning points would be the degree minus 1. 2 zeros are given. 0 is a 0, and -3 is a 0. There are 4 of them. So I will need to synthetically divide here twice, and it doesn't matter which one you use first. I'm going to use the -3 first. It looks like I have a skip at the end, so I do need to put in a 0 there for the constant. and I should get a remainder of 0. That's what that is saying. 1, negative 3, negative 4, positive 12, positive 4, negative 12, 0, 0, 0. Now, when I synthetically divide here by 0, this is the remainder, so you can cross that out. Divide it into, this is now a cubic. This is x cubed here, so don't go back to the original. You'll just create another cubic. You want the cubic to become your quadratic. So we're going to synthetically divide by 0. 1, 0, negative 4, 0, 4, 0, and the remainder is 0. So you can see your quadratic is x squared minus 4x plus 4. Factor this ideally to find the other two zeros, but minus 2 and minus 2. So I have a double root at 2. So over here I will have a double root at 2 with up and up n behavior. So bam. That's good work. All right, number 3. I like these videos. I'm doing it in front of a crowd. I'm a little nervous right now. I got phones on me. People are going to post me on Instagram. Just as long as I don't end up a may-may, that's fine. Now, number 3, you'll notice technically no hint was given. No zeros were given, but the hint was that initial polynomial factor to begin with. So just like number 4, you could see down below number 4 is already in factored form. So that is your hint that it factors. You always want to check to see if your polynomial factors to begin with. So number of zeros here would be 3 with up and down n behavior. The y-intercept would be at 0. Turning points 2. To find my zeros, I got to do some factoring. So I'm going to factor out a negative x, leaving myself with x squared plus 2x minus 8, and then a plus 4 and a minus 2. So my zeros would be at 0, negative 4, and positive 2. 1, 2, 3, 4. Bam, bam, and shazam are my intercepts with up and down n behavior. And we are rocking and rolling. Man, this is fun. Can barely contain myself with so much excitement. I think I did that right. Okay. Number 4. Actually, why don't you, at this point, why don't you pause the video and try number 4 on your own. Go ahead and pause it, and then when you're done with it, click unpause, and then Buczkowski will rock it. Go, pause. Okay, welcome back. Hopefully that went well. All right. So this guy, I got my class laughing at me. This guy, number of solutions, 2, 3, 4 solutions. Okay. Again, with up and up n behavior, even and positive gives me up and up. The y-intercept here, again, plug in 0 and evaluate it. So 0 times anything is going to be 0. Maximum turning points, the degree minus 1. And the zeros would be, I have a double root at 0, and then I also have roots at negative 3 and positive 3. So 1, 2, 3, bam, bam, and you guessed it, shazam. All right, so up and up n behavior, double root at 0, so we got a little W here. Looks like the Cubs won, bam, bam. Ooh. Nice. And again, these relative minimums down here, I assume, will be the same. And you could evaluate those, again, by picking the halfway point, which would be at negative 1.5 and positive 1.5. That would tell you the actual relative minimum values. Okay, so a little bit different here, okay? And the reason this guy is different is because, as you can see, 3i is a 0. That doesn't help me as far as the intercepts go. So because 3i is a 0, you know so is its partner, negative 3i. 3i can't come to the party without his partner. Kind of like my wife, she's always tagging along. Sometimes it's annoying. But no, she's all right. I mean, she's oh, wait, I'm getting off track here. Sorry. All right, back to the math. Negative 3i is a 0. So what I would suggest you to do, instead of synthetically dividing by 3i and negative 3i, and of course you could, I would, remember, if we think about this as factors, plus 3i, if I were to FOIL this out, we get x squared. Positive 3xi, negative 3xi will cancel. Negative 3i squared is really a positive 9. And we know we can't synthetically divide when that is a quadratic. So we gotta go here to polynomial long division. Yay! I'm so excited. I just can't hide it. I'm about to lose control and I think I like it. Okay, number of solutions. Let's add 4 solutions. The degree with negative leading coefficient, down and down, and behavior. Y-intercept will be at 0, 18. Maximum turning points is the degree minus 1. I know 2 zeros. I know 3i and negative 3i are zeros. The other 2 will come from after I long divide by this quadratic. I will have a quadratic remaining, and that will tell me my other 2 zeros. So here we go. Divide, multiply, hang on a sec, 0x cubed minus 9x squared. Subtract and bring it down. Do it all over till you can't bring down anymore. Divide. Seriously, erase that. It's already going to be, I don't want to be on a May. Okay? Negative x squared minus x. I hope I'm doing this right. By the way, the remainder should be 0 here if I'm doing this right. So divide, then multiply or distribute x cubed minus 0x squared minus 9x. Change the signs. 2x squared. Looks like that cancels. So plus 0x. And then plus 18. Bring down the 18. And then divide one more time. So plus 2. And this better give me a 0 remainder, or I did this problem wrong, and I'm going to cry a little bit. Plus 0x, plus 18, subtract, so change all the signs. Bam, 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 and I do get a 0 remainder, so yay. So my other 2 zeros are going to come from this quadratic. I'm going to factor out a negative 1. Plus x minus 2. I had people recording me while I was singing there. Like I'm not already recording myself. I mean, that's a little silly, isn't it? But whatever. What do I know? Minus 1. So my other 2 zeros would be at negative 2 and positive 1. So goldfish. We don't want to write that as an ordered pair. Those are 2 separate points there, right? Negative 2 and positive 1. So negative 2, positive 1, all right, with down and down end behavior. So what I have, I think here is a situation where I got to have a turning point now above the x-axis because of those imaginary roots. That thing's not going to cross it. And I think you get an answer similar to that. The y-intercept, this guy would be at 18 if we were drawing that to scale. Whew. Man. I think that's right. That's good. It's fun stuff. Okay? So 6, same game. Same game, except we try to trick you a little bit. If x minus 2 is a factor, that tells you that 2, 1, 2 is a 0. So if I were to synthetically divide by 2, oh, by the way, I'm so silly. Look at this guy. That guy factored to begin with, didn't it? Didn't that group? Oh my gosh, how silly. That's a little creepy, isn't it? It's a little Pee Wee Herman action there. You guys know Pee Wee Herman?
Oh,
yeah. Yeah? Was a 0, -9, -18, and 0. So we get x squared minus 9. Oh, that's nice. That's the difference of squares. So you could factor it. You could have solved it by square root. It's all good. Anyways, back up to the top. This factor to begin with. So -3 and 3. I'm kind of working backwards here. Number of solutions 3. Odd and positive is up or down and up end behavior. Y-intercept is 18. Maximum turning points is 2. Negative, bam, 1, 2, 3, bam, down and up. Down and up. Woo! This is so much fun. Number 6. Okay, moving on here. Oh my gosh, how many of these are there? 7. All right. 7's a trinomial. So most trinomials factor to begin with. Don't they, Karis? They don't. They better factor. They better. It says hint factor out of -1 first. So what's that hint all about? What if I factored out of -1? I got x to the 4th minus 10x squared plus 9. Well, this is just a trinomial numbers game. So this guy is just going to go x squared minus 9 and x squared minus 1. And these are both dots. These are both the difference of squares. X plus 3x minus 3, x plus 1, x minus 1. So folks, again, Friday's lesson, I'm not giving you hints. You're going to need to recognize that trinomial factor to begin with. Best recognize, right? 4, down and down end behavior. Y-intercept is at 0, -9. Number of turning points is 3, and my zeros would be at -3, +3, -1, and +1. So there's -1, 2, 3. Bink, 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 bonk. Down and down. We got this. With a y-intercept down here at -9. I'm even going to go down here -9. So we're going to go, what I say, down and down. So we're going to go wham, bam, and thank you, ma'am. I like it. I like it a lot. Okay, number 8. You can do number 8, folks. You can do it. I'm going to pause the video. I give you a hint. I'm telling you 3 is a 0. You can do this, folks. Pause the video and try it yourself. Psst, it also groups. Go ahead, pause, go. Hey, how'd it go? Hopefully it went well. So what'd you guys do? Did you guys use this 3 as a 0? I probably would have, but again, This guy grouped as well. I'm going to do it differently than you did it. I'm going to take x cubed minus 3x squared as a group, and then x minus 3 as a group. I'm going to factor out of x squared here, leave myself with x minus 3. Nothing to factor out here, so you just take out a 1. You get x squared plus 1, which is what you were left with when you divided by your 3. So you knew that 3 was a 0. That was given. So what are the other two zeros associated with x squared plus 1? Well, set that equal to 0. Subtract 1 from both sides. And you get plus and minus I. Again, you can see here that imaginary numbers always come in pairs. 3 zeros, down and up end behavior. The y-intercept is at 0, -3 with 2 turning points. So 1, 2, 3, the only real 0 I have is right there at 0. And you know what? I don't really... -3. How do I know where the other... I think it's like this. Like so. All right. Nice. We're almost done here. Number 9. All right. So I'm going to ask you again to pause the video here for 9 and 10. You should be able to do this on your own. So you'll see I would, on both 9 and 10, I would do long division here since 7 i's are the factors. So go ahead, pause the video. When you're done, click go, and I'm going to rip through this pretty quickly. So pause. Okay, hopefully that went well. Again, 7 i's a factor. How'd you do this? Did you synthetic or did you long divide here? Because I would have down and up 0, -49. Number of turning points is 2. 7i, -7i. You could have long divided by x squared plus 49. That's the factor associated with plus and minus 7i. But folks, I would have grouped this. Again, if it groups, if it factors, that's the direction I'm going. Should get the same answer here, x squared. And you get an x minus 1. Then you pull out your plus 49 here. Oops, sorry, plus 49, and you're left with x minus 1. So you're left with your factors of x squared plus 49 and x minus 1. So there's your x squared plus 49, and then your minus 1 tells you your real 0 is at 1. The y-intercept way down here at -49. So with down and up end behavior. Okay, 10. 1, 2, 3, 4, 5 terms. I have no chance here in terms of grouping, at least not yet. So the factor associated with 2i and -2i would be x squared plus 4. So I am going to have to long divide here. X to the 4th plus x cubed plus 2x squared plus 4x minus 8. So divide. X squared. 4 times x squared is a 4x squared. I should have put a 0x in here. Sorry, that should be a 4. And that should be an x cubed. And that should be x squared. So minus, minus, minus. Cancel. X cubed minus 2x squared, and bring down the 4 plus x. X cubed, and then plus 4x, This is a 0x squared, minus, 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 cancel, negative 2x squared, cancel, minus 8, and then a negative 2x squared, minus 8 plus 0. So hopefully then x squared plus x minus 2 factors into x plus 2, x minus 1 to tell you my other zeros are negative 1 and positive 1. 4 zeros, up and up, 0, negative 8, with 3 turning points. And we're working here negative 2 and 1. With a y-intercept down here at negative 8. Up and up end behavior. I'm going to go bam, number 10. And then the last page, write a polynomial of least degree that has real coefficients, the given zeros, the leading coefficient. So we know A here. We don't have to solve for A. All we have to do is write this guy in factored form. So this would be in factored form would be x minus 1 and x minus 1. And then these two guys together would be x squared plus 1, and then general form would be to FOIL it all out. Nice, so I'm going to work up here backwards. I'm going to go x squared plus 1. I always like to go binomial, and if I FOIL this, minus 2x plus 1. I always like binomial times trinomial, so x to the 4th minus 2x cubed plus x squared, and then x squared minus 2x plus 1, and that would leave me with x to the 4th minus 2x cubed plus 2x squared minus 2x plus 1. Excellent. You can do 12. Pause the video, try 12. Same game. So in factored form, again, we're looking at x minus 3, x plus 3. If 5i is a 0, so it's negative 5i, and that should be x squared plus 25 if you were to write that and FOIL it out. And then general form, factor this out. Well, these guys, if I were to FOIL x plus 3, x minus 3, those are conjugates of one another, so that's x squared minus 9, and then x squared plus 25. That's just a nice, easy FOIL problem. So you get x to the 4th, you get a 25x squared and a negative 9x squared, and then shoot, negative 9 times 25, that's what, if I got 9 quarters, I got $2.25, negative 225, right? Whew. Negative 225. Those two terms are like terms. X to the 4th plus 16x squared minus 225, general form, and that is the lesson. Have a great day. I'm out.